going to do here today are, they should be in your Chapter 9 notes, and it's just right after Section 9.3. And we're going to talk through the quadratic function notes that we did earlier by hand. We did them, I think, a little bit at the end of first semester, at the start of second semester. So this should be maybe the third time that we've seen this. But I'm going to show you how you can use this Desmos calculator to help answer these questions. All right, so the first thing is to review that we have the three different, for quadratic functions, we have three different forms that you need to be familiar with. Okay, the first one is, oops, they tend to call it general form. So general form, and I'm going to use slightly different lettering here because this is the lettering that we're going to use on Desmos. And if you recall when we did linear regression, we used y sub 1 is similar to. Okay, so standard form is ax squared plus bx plus c. Now remember, because we're using points on the table that we create, we're going to use x1 and y1 as our variables. It also is how Desmos sets that up. The second form is vertex form. Vertex form, again, is the leading coefficient a times x minus, or x1 minus h squared plus k. Again, we're going to use x1 and y1. And then the final one is the intercept form. y1 is similar to our leading coefficient, and then x minus p, so x1 minus p times x1 minus q. And this gives us our x-intercepts, right? So these are the forms where you're given, or were the three different forms of your quadratic functions. Okay, the advantage to this is in vertex form. The vertex is hk. Probably the easiest thing to see here in the general form, the y-intercept is 0c, whatever that constant is. And in intercept form, you can find your x-intercepts, and it is p0 and q0 as the coordinates of your x-intercepts. So that is helpful because whatever information you need in the problem, you can choose one of these three forms, and they all work from the same table of values. Right, so let's say that you want to convert something into the standard or general form. If that's the case, you need to expand it out, right? Now, we did this by hand by expanding this function and then writing your answer in that general form. If you use Desmos, what you can do here is you can simply type the equation in. So we're going to type this function, f of x. Notice you can use function notation in this, is equal to negative 3 times the quantity x minus 3 squared, all plus 12. So notice I entered this in vertex form because that's the form that it was given to me. Now, what I want to do to be able to convert this into the other two forms, and the form that I want here is going to be that general form, the expanded form. What you need to do is you need to create a table of values for this equation. So what I'm now going to do is I'm going to use this plus symbol, and I'm going to add a table. And I'm going to pick, I need to pick 3 points to create this equation, or this function. So I'm going to pick 0 as 1x input. And then I don't have to manually solve for this. I can simply use function notation, and I can put f of 0 as my corresponding output. Okay? I can then do 2 other points, 1 f of 1 and 2 f of 2. And you can choose any points that you want. But notice here it's plotting those points for me, like from that. Okay, but once you get 3 points set up in your table, and these are all 3 points that fall on the given equation or on the given graph, okay, what you can now do is you can call out any of these other forms that you want. So we want to put it in standard form, so we're going to call out y1 is similar to a times x1 squared plus bx1 plus c. And notice when I go down and look at that, it gives me all of my coefficient values. So now when I write my equation, my a value is 3, so negative 3x squared, plus my b value is 18, so plus 18x, and my c value is negative 15, so minus 15. And that is your equation, nice and easy, okay, from that form. All right. What if we wanted to find vertex form? Okay, what I'm going to do is I'm going to go back up here and I'm going to change my original equation to this second problem here. So I'm going to come up here, I'm going to delete what I had, and I'm going to rewrite the new equation, negative 4x squared plus 8x plus 1. Notice I don't have to change anything in my table of values here, right, because that's going to adapt to whatever my original function is anyway. And so if you confirm this, right, would you expect our a value to be negative 4, our b value to be positive 8, and our c value to be plus 1? Yeah. So this regression equation now confirms what we had in this given general form, but I want it to now write in vertex form. So you have a couple options here. One, once you see the equation written here, you could just find your vertex, right? I know that my vertex for this, the HK value is 1, 5, right? I can see that on my graph. So I could, if I wanted to, I could just plug this in. My A value stays the same, negative 4, x minus my H value, which is 1 squared plus 5. So to me, that's going to be the easiest way to solve this. Using Desmos, but also incorporating what you know about the function and what it provides for you. It tells you what the vertex is. But if we want to use this exact same form and confirm those, we can go down here and we can type the general form, or this regression form of vertex form. So if we go y1 is similar to, we're calling out the regression equation, the leading coefficient a times x1 minus h quantity squared plus k. And notice here, again, when you do that, you get your a value negative 4. That's the number in front. Our h value, x minus our h value is 1. Plus our k value, which is 5. So notice this confirms what we see, or what we got when we kind of incorporated the mental calculations as well. All right, and that brings us to our final form, this intercept form. So again, I'm going to go back. I'm not going to delete these because I want to keep them because these are just the different forms of my equations. But if I change my original function now to this last example, negative 3x squared plus 6x plus 45, and I want to write it in intercept form, again, I could just look at my intercepts. So if I was doing this by hand, I know my a value is negative 3. I know my form is x minus p times x minus q. Well, your p and q are these intercepts. So I know one is a negative 3, so minus a negative 3. The other one is a 5, so minus 5. So again, the easiest way to solve this would be to incorporate both the graph. So you see the graph and then take what you know about that intercept form and just plug in your two intercepts, and that gives you your answers. But again, just to confirm that you can come down here and you can use the regression equation. Y1 is similar to a times the quantity x1 minus p times x1 minus q. And notice it gives you those intercepts. You saw them here, negative 3 and 5, the leading coefficient of negative 3. And so once again, it would confirm that you are getting that value as well. And so all of the stuff that we did by hand the last time through, you can use, set up a table, write the original function, set up a table of values, choose 3x coordinates, and then evaluate the f of whatever those are. And then you can recall the regression equations to find your answers. All right, questions on that process of what we did here? While you're doing that, I'm going to rewrite how to find this, specifically how to find the vertex for each of these. Remember, the vertex in general form is negative b over 2a, and then evaluate the function for that. The vertex in vertex form is just hk, so that stays. And then for intercept form, the vertex is the average of the x-intercepts, and then plug that number back into the function and evaluate to get your answers. The nice thing, or the easier thing with Desmos, is you can just sketch the graph, click on the vertex, and you have your answer. And so again, I'm not going to delete the 3 regression equations that I wrote. I'm going to leave them here. Okay? I'm not going to delete my table of values, but I'm going to hide them for right now until I need one of them. That way it doesn't show up on the graph. And if you want to hide these points here, you could click this button to hide them as well. But what I'm going to do is I'm going to type my first given equation, negative 9x squared plus 7x minus 2. I simply need to go to my equation. If I click here, I can see my answer now. This is where it might be helpful to get an answer as a fraction and not a decimal. Although if you enter your decimals, the decimal value here, you should get the correct points for that. But if I want to find the vertex based on this, I'm going to go to my vertex form, which is this form right here. And if I do that, what I can see is my h and k values. If I just type h in my answer field and hit fraction, and type k into my answer field and hit the read it as a fraction or convert to fraction form, this allows me to see that the vertex for my first one has an x coordinate of 7 over 18, a y coordinate of negative 23 over 36, and that, bless you, that is my correct answer. Okay, so again, it makes it nice and easy. Just pick up the correct form of this and you have your values. Okay, for the second one, you shouldn't have to do anything, right? This is in vertex form. So what value of x gives you a 0 in here? 6. What is our constant on the outside? Negative 1. And so that would be your vertex. If you, so if we go back in, if you wanted to, you could type that whole equation in, however, to confirm negative 5 times x minus 6 squared minus 1. And you see, here's your vertex, 6 minus 1. It's what you were expecting anyway. And then for the last problem here, if we type in the given equation in the intercept form, and then view our equation, or view the graph. This is, I mean, again, it's an exact number, so negative 6.5 is precise. Negative 25 is the corresponding y coordinate. And once again, you find your equation, or you find your answer very quickly and easily. Thanks, Davis. If you wanted to change into a fraction, what you can do is go into a form where h and k would pull up, like this one here. And so here, if it's, like for this one, negative 6.5 is an exact answer, so I don't even know. Let's see if it, yeah, so I guess this one you would have to just type it in and then hit this fraction form button, and it would put it into that fraction form for you. But usually, like if you, like up here, usually you would see that same fraction form button to the left of this. If you don't see it, just retype that number in its own answer field, and then you can toggle back and forth between the decimal form and the fraction form. All right. So what I want you to do is see if you can answer, skip this one for right now, but see if you can answer all of these parts of this question here using the Desmos calculator. And again, I'm going to write the vertex form here. All right, so a couple things here. Again, the most common mistakes are going to be forgetting the subscript of 1 for the x and the y. Remember, that's calling out your table of values. And now, here's the thing. If you're taking this given equation, so there's no points provided, so I'm going to set up my function first, x plus 4 squared minus 1. Okay, so here is my graph. And if I just start looking at what I can get just from typing in that equation, I have my vertex, negative 4, negative 1. I have my y-intercept. Remember, the graphs always show x-intercepts, y-intercepts. In this case, now you have your vertex and then any intersection of graphs. So my y-intercept is 0, 15. My x-intercepts, again, I can see right here, -3 and -5. Okay, my domain, I'm going to have to find that on my own. Remember, the domain for quadratic functions is all real numbers, -infinity to +infinity. The range, when I look at my graph, I have a point at -4, 1. So right here is my vertex. Remember, when you select this, the first thing you're going to do is plot your vertex. Next thing you do is plot a second point. So you can choose any of these. You can pick -3, 0, -5, 0, 0, 15. There's not enough room for that one. So I'm going to go, So I have my vertex, -4, -1. So there's that point. Okay, and then my y-intercept, or my x-intercept is -3, 0. So if I pick this as my second point, it's going to create my equation or the graph for me. And now I can see the range is the lowest y to the highest y. Oops. And so my lowest y is -1. My highest y is infinity. You can never reach infinity, so parentheses there. The -1 is a closed dot included, so it's going to be a square bracket at that. And then finally, the equation of the axis of symmetry is always the line x equals whatever the x-coordinate of your vertex is, so -4. And that would be all of your information. You didn't have to use any of the tables. You didn't have to use anything else for that. You just got it by typing in the equation. All right. If you haven't already, let's try the next slide. See if you can answer all of the questions for this. Again, I'll kind of put the standard form up here in the regression equation. All right, so if we're looking at answering this, I'm going to go ahead and use function notation here because I might have to call on some points. So f of x is equal to -x² minus 2x plus 3. And I'm just going to see what I can find. So my vertex is -1, 4. Okay, my y-intercept I see next is 0, 3, which I can confirm from looking at it. That's my constant right here, yes. I have my x-intercepts are 1, 0 and -3, 0. So again, they're not decimals, so I can enter them. Now my domain, all real numbers, as is the case for all quadratic functions. My range, I'm going to look at my graph, so I'm going to go ahead and plot this first. So -1, 4. There's my vertex. And then 0, 3, I'll plot my second point. And so that's going to give me my equation or graph, so it plots the graph for me, and I can see my range is my lowest y value, extends all the way to -infinity. My highest y value is +4. You never include the infinities, so a parentheses there. The 4 is included, so a bracket. And the axis of symmetry is x equals, and it's a vertical line right through the x-coordinate of our vertex, which is a -1. And so there's my answer. Once again, nice and quick and easy just by typing in the equation that's provided. All right. Let's try the next one. Taking intercept form and finding all of that, sketching the graph and finding the information about it. Once again, I'll write the intercept form here in terms of how you would enter it as a regression equation. Same leading coefficient, x1 minus p times x1 minus q, and this will give you your x-intercepts p and q. All right, so I'm going to take my equation, type it in as a function. So f of x is equal to, my a value is 1, x plus 3, x plus 1. So here I see my equation, or my function, so I'm going to plot my vertex as -2, -1. My y-intercept, 0, 3. My x-intercepts, -1, 0, -3, 0. So again, I have these integer values, so I don't need to worry about trying to write them in fraction form. And now my domain, I'm going to plot this, -2, -1. My y-intercept is 3, so those are the 2 points I chose, although I could have chosen -1, 0, and -3, 0 as well. But there, it'll finish my graph for me. My domain is all real numbers for all quadratic functions. My range is my lowest y value is -1. My highest y value is infinity, never can reach infinity, so parentheses, -1 is included, so a bracket. And the equation of the axis of symmetry, bless you, is x equals the x-coordinate of my vertex, which is -2, and there's all the answers that are needed for that question. Okay. Once again, we didn't need to use the table for these. The original equation is all you needed. All right, questions on those, like sketching the graph and finding that information for each type of quadratic function? All right, the very last thing that we're going to do is how do you write the equation of a graph? Okay, and so what we're going to do here is, I had mentioned, you need 3 points in your table to write the equation. Okay, and so what we're going to do for this is we don't know what the original equation is, so we're just going to start off with a table. And when we do that, what we can do is we find our 3 points. So if I look on this graph, I see -2, 5 is a point, so I'm going to enter that. I was told a second point is 4, 17, so I'm going to enter that. Okay, and I want one more point. Okay? And so if you look on this graph, there's some points, I'm going to zoom in, that look like they're close. Like this one looks close, but there's one that I know for sure will be there, and it's because the graph of a parabola is symmetrical. So what that means is that this value right here is going to be matched right here. Okay, oops, I'm going to draw it from the vertex. So from here and from here to here. These are the same y values. So I know that this is 17, and I can find my corresponding x as -5. If I don't specifically want to count that, I can just see from my vertex, -2 to this point right here, which was 4, 17. -2 to 4 is a distance of 6. So if I go 6 in the other direction, 6 back this way, 6 units to the left of -2 is -8. And oops, so that confirms here, I read it wrong. So a -8, 17 is my other point. So if I type -8, 17, that gives me my third point based on the symmetry of the graph. And now I can call in my equation. Y1 is similar to, and I just need to choose which form do I want, intercept form, vertex form, or general form. When I look at this question, it doesn't specify. It doesn't specify, so I'm going to go ahead, you can choose any one of them. I'm going to use x minus h squared plus k. Okay, and so what I see here is my a value, 0.333. Now if I want to confirm what is that as a fraction, I can type a here, choose the fraction form, and I get 1/3. So I get f of x is equal to 1/3 x minus my h value, which I see as a -2, squared, plus my k value, which is a 5, and I get my answer. So that's based on what I see right here for these. Now I could have written it in the other forms as well. Okay, so I could have, if I wanted to, I'll just go through these really quickly. Y1 is similar to, I could have said ax1 squared plus bx1 plus c. If I did that, I would have entered my equation as 1/3 x squared. The 1.33, again, if you want the fraction forms of these, you can type, oops. It looks like I would need to. If I want to pull up the fraction form, I had a written twice, so I just needed to delete that equation. I thought you could just minimize it or hide it, but you have to delete it completely. So here's the fraction forms of a, b, and c. And so if I was writing this, I would get 1/3 x squared plus 4/3 x plus 19/3. And because there are no x-intercepts here, I won't even bother trying to write that form, right? There's no way that you can write it in intercept form since the graph never crosses the x-axis. All right, so I want you to see if you can find the equation for this last graph here. Again, it doesn't have any x-intercepts, so you either need to be in general form or vertex form. And see if you can find your answer for that. All right. So let's look through this final problem here. Okay, so the first thing is, and I'll zoom in here. Okay, let's find our vertex is the point 3, -4. Okay, we see this point was given as 8, -9. And so if we move from 3 to 8 is a unit 5, or a distance of 5. So if we move 5 back in the other direction, we're going to get -2, -9. And so if we choose those as our 3 points, we can set up a table with those values. So 3, -4, there's my vertex, and then -2, -9, and 8, -9. Now I can enter my regression equation. Y1 is similar to, I'm going to go ahead and use vertex form. So A, the leading coefficient, times x1. Again, make sure you establish the variable, the subscript, minus h, quantity squared, plus k. And that gives me my values here. A is a decimal, even though it's like an exact decimal. If you want to put it in the fraction form, you can. And you get -1/5. Times x minus our h value is 3 squared plus our k value is -4. Okay, so here's our equation written as the vertex form. If I instead want to write it in standard form, okay, I could take y1 is similar to ax1 squared plus bx1 plus c, and that gives me, oops. There we go. So ax1 squared plus bx1 plus c, and that gives me my values of a, b, and c. And so if I want the fraction forms a, b, and c, so I could have also written this as the equation -1/5 x squared plus 6/5 x minus 29/5, and that would also work.